Hey all, today we're going to continue talking about scatter plots, and we're going to use the problems that we talked about in the last lesson. And in the last lesson, we put this data into a table, and we were able to create or find a line, a straight line, the equation of a line that best represented our data. And so now that we have that equation, we want to use it to make some predictions. And so this is the equation we found last time, and I'm using X as my temperature and Y as my electricity. And so sometimes in statistics class, we will actually write the variables in there instead of X and Y. So that might be helpful for you so that you know what is going in for X and what is going in for Y. And if you want to use that, you can. If you don't want to, you don't have to. You can leave it with Y and X because that's what it looks like on Desmos. That's totally fine too. So we can use this equation to make predictions for the amount of electricity we'll use based on what temperature it is. Now, these are only predictions, they're not guarantees, but we can make a prediction based on our information. And so we want to try and make a prediction about how much electricity we'll use at 78 degrees Fahrenheit, to be specific. So I've put our table in Desmos. This is what we did in the last lesson. I put our line of best fit into Desmos. And so there's a couple ways we can figure out the prediction. We want to find the point on the line where X is 78, where our temperature, which is our X value, is 78. And so one way we can do that is by simply typing in the equation of a vertical line where X equals 78, because that's what we want X to equal. And you can see it intersects our line of best fit, and we can click that point, and you can see the X value is 78, and that tells us the Y value is 42.391. So this is like plugging 78 into our equation to get a Y value, 42.391. So I'm going to write Y equals 42.391. And in our case, we're measuring that in these kilowatt hours. You don't need to know what a kilowatt hour is, but that's the label, the units we're using. And so we would predict that if it was 78 degrees outside, that we would use 42.391 kilowatt hours of electricity. And that's it. The other way we could do this is by using our equation and plugging 78 in for X. So let me do it that other way. I could say 0.4771 03, I'll type the whole thing in, times 78 plus 5.1771. So I'm just plugging it into our formula, and we get 42.391. We get a little bit longer of a decimal, but that's okay. We get the same answer. So you could choose whichever way you like best. You could actually type this into Desmos and plug in the X value you like, or you could graph a vertical line for our X value, find the place where they intersect, and that Y value is going to give you our prediction. So let's look at the next one. Here we had the heights and weights of several adults. And so we want to predict what would the weight be approximately. It's a prediction for a person who is 5.8 feet tall. So again, I have loaded this into Desmos. This is what we did last time. You can see the line of best fit. You can see our data points. And so we could just type in X equals 5.8 and we'll get a vertical line. You can see in black there, and you can see when it graphs that line, it's going to put a point where the two lines intersect. You can click that and you can see the coordinates. 5.8 is our X value. That's the height we're interested in. This 153.685, that's a prediction for the weight. and that's in pounds. We should put our units. So we would predict, not guarantee, we would predict based on our table here that somebody who's 5.8 feet tall would weigh approximately 153.685 pounds. And again, you could use this version of the equation. You can replace the x and y with the actual variables if you like that, if it helps you keep track of which is which. But again, you do not have to. So let's do one more. We want to use our information from the flight costs to predict approximately what a 1,000-mile flight would cost. And so I could do x equals 1,000. And I could find the place where it intersects my line of best fit. There's my x, which is 1,000. My prediction for the cost is $116 and approximately 2 cents. So we would expect approximately to pay $116.02 to fly 1,000 miles. Again, the other way to do that would be to type this right side of the equation into Desmos and replace x with 1,000. So I'll do that. I know I didn't do it on the last one, but let's do it on this one. So I could take my slope 0.0903711 and multiply that by 1,000. And then I'm going to add to that my y-intercept, 25.6466. And there we go. We get approximately the same answer, 116.0177. We'd round that to 2 cents. So we could get the same answer both ways. You can either plug in using the equation, or you can just graph a line for our what we want to predict and find the point where they intersect. Both are valuable. Both relate to other things we do this year in this class. So both are excellent methods to finding a prediction. So as always, if you have any questions about what I did there, please do ask. Please stick around and answer the questions at the end of the video. And while you're working through that, if you need some help, ask me for some help. I'd be glad to help. And take your time and good luck.